learn about U-substitution. It may seem as scary as the intro perceived it to be, but it's not. Trust me. I'm gonna walk you through two main methods of U-substitution, also known as reverse chain rule, today in this video. So let's begin. Let's start off with a definition. The substitution rule states that if u equals g of x is a differentiable function whose range is an interval I and the function f is continuous on I, then the integral of f of g of x times g prime x dx equals to the integral of f of u du. The first example we're going to see is a simple one in order to show how this substitution works. Here we have a differentiable function, integral of x to the fifth times cosine of x to the sixth plus 1 d of x. Okay, so when we look at the function, we substitute the simpler one. In this case, it's x to the sixth. We let u equals to x to the sixth plus 1. Now we take the derivative of it. It becomes d of u equals to 6x to the fifth, since we take the derivative of x to the sixth, dx. Now we need to solve for dx. In this case, it becomes d of x equals to 1 over 6x to the fifth du. Now we do the actual substitution. We substitute the x to the 6 plus 1 with u, and as we solved before, the dx is substituted with 1 over 6 times 1 over x to the fifth. As we can see, the 1 over 6, since it's a number, and no matter what we do, it's still going to stay 1. We're going to put it on the outside of the function. And we can see that the x to the fifth and the 1 over x to the fifth cancel each other out. Anything times 1 still stays the same. And that is how we get 1 over 6 times the integral of cosine u du. Now that that's done, we just need to differentiate the function. So it becomes 1 over 6 times sine u plus c. And now, finally, at the last step, we substitute the u back. It becomes 1 over 6 of sine of x to the 6 plus 1 plus u. The number one thing that should not be forgotten is the plus c. You can write it on your hand, you can write it at the bottom of the paper before even starting the problem, you can memorize it, you can do anything you want as long as you don't forget plus c, plus c, plus c. Now let's start a problem with a definite integral. The substitution rule for definite integral states that if g prime is continuous on a to b, and the function f is continuous on the range of u equals g of x, then the integral from a to b of f of g of x times g prime of x dx equals to the integral of g of a to g of b of f of u du. A corresponding example to this type of a solution would be this problem that we see right here. The integral of 1 to 4 of 1 over rad x times rad x plus 1 squared. For this problem, the simplest part would be the rad x plus 1 inside the squared. So we let u equals to rad x plus 1, then we take the derivative of down. It becomes d of u equals to the derivative of rad x, which is 1 over 2, times 1 over rad x dx. Again, we have to simplify for d of x, which becomes d of x equals to 2 radical x du. The next step would be to find corresponding integral values for the new u function. we take the old integrals, which is x equals to 4 and x equals to 1, and we plug them into what we let u equal to, rad x plus 1. When we plug in x equals to 4 and x equals to 1 for that function, we get rad 4 plus 1, which becomes 3, and rad 1 plus 1, which becomes 2. This step transforms our integral limits from 1 to 4 to 2 to 3. After the complete substitution is done, the final product we have is 2 times the integral of 2 to 3 of u to the negative power of 2 du. Now all that is left to do is to differentiate it like any other problem. The differentiable of u to the negative 2 becomes u to the power of negative 1 over negative 1, simplifies into negative 2 over u, which leads us into the final step of solving from 2 to 3. First, we plug in 3 into the negative 2 over u, minus, we plug in 2 into negative 2 over u. When we solve for it, our final solution is 1 over 3 for the end of this problem. The final overview of how to solve a U-substitution with an indefinite integral is to choose the complication, meaning choose the simpler part of the problem in order for it to be equal to u. Then replace whatever it is by u, solve for d of u, and then differentiate with the u plugged in. In the final step, insert whatever u was supposed to be substituted for, and then plus c. For substitution with definite integrals, the same steps apply, except we have to change the integrals to match the u problem, and then same thing happens, you differentiate, and instead of plus c, we actually solve for a number. We have now reached the end of our video. Thanks for watching. Happy holidays. But however, if you wish to see the other video I made regarding curve sketching, please click the middle of the screen right now, the box surrounding the words "the end." Thank you for your time, and goodbye.